I'm going to proceed to design of single reinforced concrete beam. So ito yung procedure. So yung usual na mga given sa pag-design ng beam is yung width, yung depth ng beam, yung length ng beam, yung FC prime, yung clear concrete cover, C sub C, diameter ng longitudinal bar, yung yield strength ng steel, tsaka yung factored na bending moment. So first is yung strength reduction factor natin. So we are assuming here na tension controlled yung section. So therefore yung phi is equivalent to 0.9. After that, if hindi given yung effective depth ng beam, we can approximate it using these two equations. For single layer, H minus 65 millimeters lang. Kung double layer naman, H minus 90 millimeters. If given lang naman yung C sub C diameter ng ties, tsaka yung diameter ng bar, we can make use of this assuming na single layer kung sa ating steel reinforcement. So yung D natin is equivalent to H minus C sub C plus diameter ng tie plus diameter ng longitudinal bar divided by 2. After that is to solve for the coefficient of resistance, Rn, which is equivalent to our mu all over 5 BD squared. After solving for our Rn, we're going to substitute it here sa equation ng ating required na steel percentage or steel ratio. Yung raw required natin is equivalent to 0.85 Fc prime all over Fy times 1 minus the square root over 1 minus 2Rn all over 0.85 Fc prime. After solving for the required steel ratio is to solve for the required na steel area, which is equivalent to our raw required times BT. After solving for the required steel ratio, we're going to counter check it sa minimum na steel ratio. So based sa ACI steel area, based sa ACI section 9.6.1.2, yung minimum na steel area is equivalent to the maximum value between these two equations. 0.25 square root of FC prime all over Fy BWD or 1.4 Fy BWD. So whichever is yung maximum sa dalawa, yun yung gagamitin natin na value for our minimum steel area. Then we're going to compare it dun sa nasolve natin na required na steel area. So whichever is the maximum between dito sa dalawa, yun yung gagamitin natin or mag-govern na required steel area. Yung point nitong equation na to is that dapat yung required na steel area natin ay hindi siya bababa doon sa minimum na steel area. After solving for our required na steel area, we are going to divide it by the area of our bar, which is just pi d squared all over 4 lang naman. Pi times the diameter of bar squared all over 4 para ma-solve natin yung number of bars. So usually, we are rounding it up to the nearest integer. As for example, if 3.2 yung lumabas sa nyo, sa computation nyo, so pwede na gawin nyo na lang yung 4. So for example, 3.6 yung lumabas sa calculation nyo, gawin na lang 4. Then after that is to solve for the radius of bending ng ating stirrups. 20 millimeters yung value ng radius of bending if yung diameter ng ating stirrups is 10 millimeters. If ang diameter naman ng stirrups is 12 millimeters, then 25 millimeters naman yung magiging value ng ating R. So this is necessary para masolve natin yung clear spacing ng ating bar. After that is the diameter ng ating aggregate. So yung usual na ginagamit is 3/4 inch, which is approximately 19 millimeters. And this is based from ACI table 19.3.3.1. After that, after solving for the diameter of our aggregates, is to solve for our minimum spacing. So the minimum spacing based on ACI section 25.2.1 is the maximum value between these two values. So whichever is the maximum value between 25 millimeters diameter ng bar, tsaka yung 4/3 ng diameter ng aggregate, yun yung mag-govern ng minimum na spacing. And then, after that is yung maximum spacing naman. So to solve for our maximum spacing, it is the minimum value between these two equations. 380 times 280 all over Fs minus 2.5 times Cc, tsaka yung 300 times 280 all over Fs, for which yung Fs based on ACI section 24.3.2.1 this is equivalent to 2/3 ng ating Fy. Tsaka yung C sub C, take note, this is not the clear na concrete cover na given kanina sa previous na flowchart. But rather, this is equivalent to the clear spacing plus yung diameter ng ating ties. So, after that is to solve for the spacing ng ating bars. So, this is now equivalent to our width ng beam natin na P minus 2 times ng sum ng ating clear concrete cover times diameter ng tie plus yung radius of bending ng ating stirrups minus yung number of bars minus 1 times yung bar diameter divided by the number of bars minus 1. So, ito dapat yung masatisfy natin na condition para magiging safe yung spacing ng ating bars. So, dapat yung spacing ng ating bars must be greater siya sa minimum pero less than siya sa maximum para ma-prevent natin yung pag-crack sakali na masyadong malapit yung mga spacing ng ating mga longitudinal bars. Now, sakali naman na yung spacing natin is less than sa minimum na spacing, we have here mga suggestions para ma-satisfy natin yung condition na dapat yung spacing natin must be greater than the minimum tsaka maximum spacing. So una, pwede kayong mag-select ng larger na bar diameter. Pwede nyo ring i-increase yung width ng beam or H. Pwede kayong mag-apply ng double or multiple layer na tension steel reinforcement. Pwede rin kayong mag-apply ng bundle bars. Or you can also increase yung FC prime tsaka yung yield strength ng steel na Fy. So if we're going to make some modifications sa inyong na design, magkakaroon kayo ng redesign. So meaning uulit kayo ng calculation. So kung masatisfy nyo na yung spacing, so pwede na kayo mag-proceed sa structural investigation for which you will now be calculating the strength capacity ng inyong beam such that dapat yung inyong capacity is greater than your demand.